Hi, my name is Kwame Dr. Mensa, and today I'll be doing my ADTA 5560 project. And so, beginning with my project, I'm going to show you a data set I'm going to be using for a different part of the assignment, which is a time series data set for the minimum daily temperatures in the city of Melbourne, Australia. So, this is the data set I decided to use. This is a data set with observations that I saved out, and I'll be importing that into my Google Cloud Platform virtual instance. So I will be uploading the file here. I believe I called it the daily minimum temperatures. So I'll be copying that into Jupyter Notebook. So now I have this in there, but I want this to be also in the data. So what I'm going to do is put this in the data subfolder. And I'll be working with the data set from there. So let's see. Okay, so I've been able to successfully put my data in, and for the rest of the project, I'm gonna go over creating the sine wave data in Jupyter Notebook, and so that'll be next. Yeah. So now that we're in my Jupyter Notebook, you'll be looking at the next part of the project, which which is doing with creating a simple RNN to a recurrent neural network with the sine wave data. So I'm gonna make a sine wave data here. So I'm importing my libraries. These are the libraries I'm gonna use. And so generating the data, these are the points that I use. So parameters are here. We have the date, we have the number of data points, and then the range. And so we do a little analysis on what the sine wave data is going to look like. So now we're going to split the data set here. These are already run. So I set the percentage of the data that's used for testing. And then with that being done, we're going to normalize the data by scaling to a range of 0 and 1. So these are the codes that we're going to use to normalize the data. And then the next part of this will be creating the time series generator or instance. In creating the time series generator, we have the batch size, and the length here. And then, so these are all going into creating that time series generator. And once that is built, we're ready to build a simple RNN model. This is where I'm supposed to choose the number of neurons they're supposed to use to train. And so I picked 100 neurons. And so we have 100 neurons here in the input shape. So when that is done, we have one dense layer, there's one fully connected layer here in that building that simple RNN model. So I have one simple RNN model, which has a simple RNN and then a fully connected layer as well. So this is where that part of the build is encoded. And so we're going to compile the model using the Atom optimizer, and then we're going to use the mean square, the MSE mean square error, to identify loss here. So now after that is done, the important thing is to train. We're going to fit this model. And so in fitting this model, we're going to use the time series generator that we did, and I'm going to use 5 epochs. So it's going to break it down into 5. And so when that loss is calculated, when the model is fit, we get the visualization of the loss model, the model's performance after we train it. And so this is what we have here. And so the number of times, steps of the input time series, we set that to 50 initially. And so this is just bringing that back out. And so we evaluate the model after training. So this is what we're doing here, is evaluating the model. This is the array that we have. So in looking at the batches that we have, a number of features, we have this. So evaluating this model, we reshape this. And so we're using this code here to store the prediction. So we're going to look at the predictions against the actual. And so the true predictions are going to be here. And so that is run. And so then our data set, the sine wave data set that we created is here. And so updating the data set next with the true predictions. And so we have the sine versus the predictions. And we can see that they're slightly off. So this is the sine versus our predictions. And so sine prediction. And so you want to visualize and compare, the data test data to compare with the model. So what we do here is really creating a model and then using it against the test set that are separate. And so this is the results of my sine wave data that I created. And to look at the diagram of the model of the neural network, this is the diagram that I drew to represent what went on. So we have the inputs going in and feeding into the fully connected layer. So we have that. The next part of my project, we're going to be looking at pretty much the LSTM neural network, and so that'll be for parts 3, and explaining the different concepts of the LSTM cells and the gates. And then I'm going to use the time series data that I actually imported to build a time series model for that data set of the minimum temperatures in Australia, in Melbourne, Australia. So